Hello my dear students. Already you have come to know the function of size of function. Using the size of function we can easily get the amount of occupied memory space of a variable. Now I'll show you something related to a structure. So you know that in a structure we may have different types of variables. So a structure is a group of data elements where the data elements may be of different nature. So when we declare a structure, there we mention different data elements, and after that we declare structure variables to access those structure members. Now I'll just show you some codes here. You can see that I have declared one structure which is ABC, and here I have three data members. One is one character type variable A, another is another character type variable B, and one integer variable C. Now we know that one character variable occupies 1 byte memory space, one integer variable occupies 4 bytes memory space. Now when we declare any structure, to access the members of a structure we need to declare a structure variable. So in the main method I have declared one structure variable X. Actually X is a structure variable and the structure name is ABC, and we need to declare this structure variable X in this way. First we need to write this keyword struct followed by the structure name followed by the variable name. Now we may have something in our mind then, that is, what is the size of this X? Actually using X we can access all these variables. Therefore the sum of the occupied amount of memory spaces will be the size of X. Therefore we can say that 1 plus 1 2 bytes and 4 bytes, 2 plus 4 6 bytes. So according to our calculation the size of the structure is 6 bytes. But is it so? Let's see this. Let me run this program. So first I'll compile this one. So according to our calculation the output should be 6 bytes. So let's see. Now I'm just going to execute it. Oh my god, it is showing us 8 bytes. Why? It should be 6 bytes. So here one thing I would like to say you, that is the occupied memory space of these variables are 1 byte for A, 1 byte for B, and 4 bytes for C. It's okay. But computer accesses these variables not according to the occupied space of these variables, but according to the word size of the processor. Actually, if you have a 32-bit processor, then the word size will be 4 bytes. If you have a 64-bit processor, then the word size will be 8 bytes. Therefore, at a time 4 bytes space is accessed by the processor, as in this computer the processor's word size is 32 bits. That means what is happening here, actually you see, say this is okay. Two. Okay, so for variable A, this is the place. For variable B, this is the place. For variable C, these two locations will be empty. Alright, so A and B, as they are occupying 1 byte space for each of them, therefore first 2 bytes will be filled by A and B. But if C occupies these two, then remaining these two locations also will be occupied by C, as C is occupying 4 byte space. Each box is of 1 byte space. So as I said that in case of 32-bit processor, the word size is 4, therefore 4 bytes will be accessed by the processor at a time. So it will occupy these two and these 2 bytes. Alright, if C starts occupying space from here, then what will happen? Half of C will be stored here and remaining half will be stored here. As a result, what will happen? When we will access A, B and C, these 3 variables, then how many cycles will be required? 2 cycles will be required. In one cycle, first 4 bytes will be accessed, then the next 4 bytes will be accessed by the processor, as the word size is 4 bytes. Now the thing is, if we access only C, in that case what will happen? To access C, 2 cycles will be required, because half of C is here in this part and half of C is here in this part. Therefore 2 cycles will be required. So to access one variable, 2 cycles will be required. Therefore to reduce the number of cycles, what can be done? These 2 bytes can be left empty, and in the next word these 4 bytes will be occupied by C. Therefore when we'll access only C, only 1 cycle will be required. That is a better approach. So that's why here in this program what is happening, these two will occupy 2 bytes space, but next 2 bytes will be empty. That means 4 byte space for these two, and in next word the 4 byte space will be occupied by this C. That means 4 bytes plus 4 bytes. That's why the output is 8 bytes. So if I run it again, you see here the output is 8 bytes. Now the concept of keeping empty this thing here, these bytes here, this is called structure padding. What is it called? Structure padding. So I hope this is clear to you. Let's see in the next video.